Hello guys, it's Dr. AJ. So today we have examples on shear strength of soil. Sometimes you hear the name mohr-coulomb, motor failure, or Mohr Circle stresses. So those are all basically names for the same topic. So let's get started. As you can see, example one, we have direct shear test of sand. That's very important. Keyword. Sample area is given 32 inch square. Normal load at failure is 1536 pound. Shear stress at failure 24 psi. What is the angle of internal frictions? So as usual, we start by writing down what's given. The area is 32 inches. Normal load P 1536 pound. And tau at failure or shear stress at failure 24 psi. Please pay attention. First is SI US units, and number two we're dealing with inches and pound. So you go to the FE reference manual and you see the equation. This is the shear stress at failure. This is the equation. Tau equals C plus sigma n, the normal stress, times phi. This is also called the mohr-coulomb mode of failure equation. Since we go down, we write the equation C plus sigma times phi. That's okay. And then, so sigma basically is the normal stress, right? It's force over area. Force, we have it's 1536 and the area is 32. Do a little bit of mathematics, we're gonna get a normal stress of 48 psi. So now, C is 0. Why C is 0? Because as I said, it was sand. In sand, there is no cohesion. That's why sand is a key word in this question. So C is 0. So we go back to the equation. C is 0. Tau basically is 24. Sigma, we just found that 48. We do a little bit of mathematics. So basically tau sigma times phi. And then phi basically is going to be tan inverse of tau over sigma. So we plug in the numbers. As I said, 24 is the shear stress, tau from here, and 48 is the normal stress. You do the inverse for the tan, you get 26.6, almost 27. The answer is basically A. So, example 2. Determine the major principal stress if the minor principal stress is 10 psi. Mean normal stress is 17 psi and shear stress at failure 7 psi. Okay, so as usual we start down by writing what's given. Sigma 1, what are we looking for? The major principal stress. The minor is sigma 3. Tau at failure is 7 psi. S is the mean normal stress. You go down to your reference manual. This is basically the Mohr Circle, the shear stress diagram. Sometimes it's called mohr-coulomb failure mode. This is the equation we just saw a couple minutes ago. Tau at failure equals C plus sigma and times phi. So everything is given, and most of the questions in the, not most, honestly, like all the questions in the FERP are conceptual questions. You're not going to get tricky questions. They want to know if you know the concepts well enough. That's basically the behavior of the exam. So we're looking for sigma 1, right? Sigma 1 is basically the distance. Please pay attention with me. The distance from here to here. This is all sigma 1. Sigma 3 is from here to the touch of the circle. That short distance. S is basically the distance from here to the center of the circle. Tau failure is basically the radius of the Mohr circle. This is the radius. So from here to here, here to here, this is all tau failure. So sigma 1, there are basically two ways we can solve this since we have quite a few of stuff given. So the first way, sigma 1 is equal sigma 3 plus 2 times tau failure. So sigma 3 basically is going to give us from here to here, as we said, right? And then we need the entire diameter of the circle. But we know tau at failure is the radius. So times 2 will give us the diameter, right? And then we add that to the sigma 3. So everything is given. sigma 3 is 10 given here. 2 basically to convert from the radius to diameter, and the tau failure is the radius, 7 psi is given, so it's going to give us 24. There is another way, since s is given, which is the distance from here to here, we can add that just to the radius, and then we can get the sigma 1. S is 17, plus 7 is the tau failure, the radius, we're going to get 24, and that's going to give us basically the answer is C in this one. Example 3. Determine the mean normal stress, maximum shear stress in cohesion for the clay soil. Clay soil is a key word here. It's like the first example, we say sand, then C equals 0. Clay, C means it's not going to be 0. We're going to be using, from what's given basically, we have to use the shear normal stress equation, or mohr-coulomb, the failure mode equation. So, as usual, we start by writing what is given. Clay soil, phi is given, sigma 1 is given, sigma 3 is given, the sigma normal is given. Okay. What we're looking for, the mean stress, tau failure, and the cohesion. So, simple and easy. We go to the reference manual, we go to the shear stress Mohr Circle figure. So you go there, and then first of all, we find the S. What's the S? Is basically the mean. It's sigma 1 plus sigma 3 over 2. As I said, sigma 1 is from here to here, sigma 3 from here to here. And we're looking for the mean distance, for the mean. So sigma 1 plus sigma 3 over 2. You cannot do sigma 1 minus sigma 3, because that's going to give you from here to here, and it's not the same from here to here. This is very important, guys. Please, the drawing, the figure itself is not to scale. So, S is basically the average. It's from here to here. That's why we put sigma 1 plus sigma 3 over 2, because we're looking for the average. The distance from 0 to sigma 3 is not the same as from sigma 3 to the middle of the circle. So, sigma 1 plus sigma 3 over 2, we're going to get the average. Sigma 1 is given 30, right? Sigma 3 is given 15, divided by 2, 22 and a half, and that's going to give us S 22 and a half. Now we're going to go to the tau failure. It is the radius from here to here, right? And because sigma 1 is given from here to here, and sigma 3 is given from here to here. So if we basically subtract sigma 1 minus sigma 3, we're going to get the diameter, right? And then if we divide that by 2, we're going to get the radius. So sigma 1, 30 minus 15 divided by 2 is going to give us 7.5. And that's the tau failure. The final one is C, the cohesion. This is basically the equation from the diagram, or you can easily go to the reference manual, and it looks like this. Tau equals C plus sigma and tau phi. You can get it from here or from here. It's up to you. I would just stick here, since you're given, like the moment you're gonna get given the sigma 1, sigma 3, I want you to go directly to the figure of Mohr Circle, because you're gonna get everything in that. So I don't want you to waste time back and forth, and even though they are on the same page, but just to make it simpler for you. So C, tau, we just found that. Sigma n is given, phi is given, C is what we're looking for, right? 7.5, that's tau. C, we don't know. 20, sigma n is given. Tan 17, please pay attention. You're gonna substitute that in the degrees. So we do a little bit mathematics, and then tan 17 for degrees is 0.3 times 20. The results basically will be subtracted from 7.5. We're gonna get 1.38, almost 1.4. So since S is basically 22.5 and tau failure is 7.5, that's basically the answer to C for this one. So with that, thank you very much, and see you next time.